This is Alan, and my project of statistics is random truly random. And here's the background. Random is a commonly used function in Python to generate random digits. For example, using random randint to generate output 3 random integers from 1 to 5 and including. The result is here as shown. So it appears 3, 3, and 5. Theoretically, the appearance of each digit 1, 2, 3, 4, 5 is independent, and the probability is the same, 0.2. However, in this case, 3 appears twice and 5 appears once, showing a different probability. So is a random function truly random? Can it properly serve the goal of producing random digits? It's planning, designing a program to generate a large number of digits and compare the result with expected result. In practice, I will compose data and conduct chi-square tests for goodness of fit to see if there tends to be difference between experiment result and expected outcome. So here's a data collection program. I will import the random function and set 6 blank variables to store counts. And here set a blank set to store generated integers. And here I use a for function to construct 100 rounds of generation and store integers in the list. And in these 5 lines, I store the count of integer in each variable. And thus, I output all these counts. And as the output, you can see the actual output here and the expected output. It will be equal for 5 integers or 20. And the bias, there could be weird counts that are extremely small, for example less than 5. So I use 100 generations so I can avoid extremely small count. And for the sample size, each count is significantly larger than 5, and the sample size does not exceed capability of calculating and graphing application. So I don't think there will be missing data and abnormal data. And for the data description, claim is as shown. The null hypothesis, the stated distribution of counts of integers of 100 generations, is correct, and the alternative hypothesis, the stated distribution of counts of integers of 100 generations, is not correct. For the condition, for the large counts, each count is larger than 5, as shown 13, 18, 17, 11, and 21. For the random part, the counts come from a random sample. And for the 10% part, the number of trials is necessarily larger than 1,000 for a population. The result of chi-square test is as shown. The test statistic is 7.2 and p-value is 0.1256 and degree of freedom is 4. The graph is skewed to the right, have an infinite spread, and the center is at 1.976, and I think there's no outlier. At significance level alpha equals to 0.05, p-value is larger than alpha, failing to reject a null hypothesis. The hypothesis of there are equal counts of integers among 100 generations of random is correct. And in conclusion, according to this experiment, the random function can serve as truly random. That's all for my project. Thank you for watching.